Hello again, everyone. Welcome. I'm introducing the computer interface. The interface looks like this, a few tabs. Our tabs include device testing, AI assistant, power supply, operational testing, help, maintenance, training, and catalog. The help section prominently includes the user manual for HVD-Orion, which provides detailed guidance. In this manual, you can find comprehensive information on how to use it and exactly what each button does for operation. Live chat and the contact section are there for you to communicate with the technical team and get information from them. Below that is the frequently asked questions section. This section contains frequently asked question headlines and relevant topics. Here you'll find question problem headlines. You can quickly access solutions to problems beneath these. Next tab is indeed the maintenance tab. The HVD-Orion contains many computers. It can run its own tests, allowing for quick fault diagnosis. Each module internally measures its own voltages and outputs, meticulously sending them to the computer system. The computer then rigorously checks their accuracy and precisely pinpoints any potential faults that it may detect. Whether it's a communication network, relay systems, or voltage sources, we are able to easily accomplish these tasks with a self-test button. Next tab is the training tab. You can access videos I've mentioned here, like videos on EBS or ECAS repair right here. Actually, we offer it as a visual PDF document, and we also have videos like this. You can easily access them here. You can find helpful videos on EBS repair, EBS connection, and HVD-Orion problems listed under those specific titles. I can't access the e-catalog right now because this is a commercial section where repair kits, EBS, and APM subgroups from various brands are commonly sold. You can easily make purchases from here. Operationally, it works like this. We have outputs, and also we have inputs readily available right here for use. You can adjust these inputs here as you like. For example, you can bring it to 4 bars and get an output, or thanks to the 8-bar ratio source, we have 3 or 4 outputs here. We have 4 more inputs again. We can read this. For example, we assign the inlet pressure here, we can read it. We also have a digital power supply on the device. From here, we can easily set the desired voltage and also limit the current to get the output. Again, on the device, we can manually read the inputs located on the MVD from here. The power supply section allows us to easily adjust our power supply to specific voltages and limit its current. We can turn it on and off simply. The AI assistant part is very advanced indeed, and quite impressive to see and consider, but briefly, for example, in this latest test scenario, they carefully examined the solenoid's response under pressure within this comprehensive EBS test setup. Information like the solenoid opening time and voltage is stored here, and a lot of data circulates on the device. Artificial intelligence meticulously analyzes this information by storing it during testing. Through this detailed analysis conducted on numerous machines, the typical reactions of specific solenoids and EBS are now learned with the aid of artificial intelligence. These reactions come with predictable consequences and results. Here's another detailed analysis. Here, solenoid opening reactions and related data, such as opening times, are carefully measured with comprehensive data. Here are graphs precisely illustrating the opening and closing of a solenoid. Here they were sampled and analyzed. This is exactly how it is. In the device testing section, we have a few tabs again. The EBS measurement section. There are many EBS modules available on the left side. The desired EBS will be tested from these. The EBS can be selected and the testing process can be performed. For example, the EBS 224 module that we tested before, specifically in our previous video tutorial. That's the general information for the module. You can see the basic details, technical specifications, and important values like the number of sensors, speed sensors, and wear sensors on the module here. Toolsets are readily available below. And in the bottom right corner, there's a repair video. You can see a video we previously shot, for example, right here. Let's say Tamir assembly information, and here's the video. Installation details are also available here. You need to plug it from the output of HVD-Orion to the input of EBS. After that, you can see clear step-by-step instructions and details on how to navigate the program. We have manual and automated testing sections. Manuel was testing connecting to EBS, and you can have whatever bar you want delivered from EBS through here. You can read your own outputs. You can easily read the outputs of the HVD. You can also see the data from the EBS module and the data coming over CAN from here. And again, you can see the tests displayed here. Let me go to the automated testing section. We're looking for something similar in the automated testing part. Okay, you can see the data from the EBS, right and left channel pressures, left and right speed sensors, and again, you're seeing the right and left speed sensors. And here you can still see the outputs in segments. You can see the channels voltages, pressures, and left and right speed sensors, as well as the values of the wear sensors. We have a few test modes in automatic testing. First, you can apply 3 to 6 bar. Second, we send signals to the EBS in the form of 2 to 5 to 8 bar, requesting the creation of these pressures, and then compare them with the pressures coming to the HVD to confirm whether it is working correctly. We also have a 30-second test here. Okay, so in the test steps, first when we say prepare, a specific scenario will be applied to EBS. Apparently, the scenario is being sent by computer to the brains inside the HVD, and those brains are applying that scenario to the EBS. When we say start, the scenario application begins, certain pressures start being applied to the EBS. After that, you can see the scenario step by step in the test steps section here. Again, you can see the pressure outputs coming from the HVD inputs. And finally, at the test end, you can see the test result displayed here, such as OK or defective. And also from the show report section below, you can see the type of test, which HVD is installed, and which EBS is installed from here. When you say print a report, you can see detailed information here about whether the test phases are sound or what's broken. You can easily give this report to the customer or store it yourself for a retrospective report, which can be quite important. In the sensor measurement section, we still have many sensors. Our pressure sensor has various sensor options available. You can see the information for these sensors here. The interfaces are generally similar. Sensors are categorized into ECAS, EBS groups. On these screens, you can see the inlet pressure, the pressure coming from the sensor, and the pressure applied to the sensor. The prepare part is applied within a certain scenario in the sensor. Okay, when we say start, the brains inside the HVD are indeed applying that algorithm to the sensor. They're running this specific scenario. Here you can see the test steps again, and clearly when you say report, you can see the report result, all stages, and what was done in great detail. In fact, we also have many ECAs available in the ECAS section. Okay. You can select what you want and change the information here. According to ECASA, each ECAS has its own specific information. You can also see the real-time pressure of HVD's inlet, outlet, or main feed tank. Similarly, when you say prepare, the scenario that is carefully prepared by our service on the computer is sent to the brains inside the HVD by the computer. These brains also apply the scenario to the ECUs. When you press start, you can again see the scenario in the test steps section. Depending on the scenario, you can still monitor information such as rising pressures and sensor data from here. The report display section is also conveniently available here. You can easily get the performed operations and their results as output in the report section. There are many APM options readily available here. Many options are available, including Mercedes, Ford, Scania, and more brands. For example, with the Mercedes APM, you can quite easily see information like inlet pressure, outlet voltages, and temperature by connecting manually to it. Right, depending on the APM, some have automotive Ethernet and LIN bus, while others might not. CAN communication might be present. Different connection configurations exist. Here, once the connection is made, the LED indicator turns green. We can tell the connection is made from here very easily. As with other tests, there are prepare and start buttons here as well. Looks like the script is being sent to the brains again. The brain then applies the script to the APM system. You can see step by step exactly what is being done in the test steps, such as which sensor is working correctly or not. We can get the report output here too. In the operational test phase, we can still manually provide the outputs. We can adjust the outlet pressures here, or we can read the inlet pressures. Digital power supply is present here too. That's all there is to our basic interface that is currently available for you to use, explore, and fully test and evaluate for now, folks.